front, let's see, we had 1 decimal place, and so 1 decimal place, the 4 rounded up to a 5. This one, you could have written 2 sig figs. Did anybody choose something other than 2 sig figs to put there? There were other choices, right? 2 sig figs works, though. This one said the nearest millimeter, so you had to first convert it to a millimeter. How many millimeters are in a centimeter? 10. So your decimal moved over here, and then to the nearest millimeter, that 4 still rounded up to a 5. To the nearest 100 centimeters. So this one, they had 2 sig figs. This one, they said to the nearest 100 centimeters. 4 sig figs. So 1, 2, 3, 4, and the 2 does not round up. And then this was 5 sig figs. This was 1 sig fig, not very close to this number at all. And this one was the nearest 1,000 centimeters. So some of those might have been hard to come up with in the middle here, but you should at least have been able to get these answers on the outside. Did anybody have any questions on the warm-up? Okay, so the most important of all these rounding methods is the significant figures, because that's the one that we use the most in IB, okay? We use decimal places only for money. All right, we need to learn about 2 things called relative error and percent error, and the wording down here is actually not the best wording. This wording is the best wording, and it's the same for both. You see how the relative error is the same as the percent error. You just multiply the percent error times 100%. So I'm just going to repeat this. It's approximate minus the exact divided by the known value. When we talk about relative error or percent error, we're just trying to decide, is this a big error for this situation, or is this a small error for this situation? For example, if I made an error of $2 when I was giving change, but I was just giving change for a $5 bill, that's a pretty big error. But if I made an error of $2 when I was giving change and it was for like a bill of $10 million, that's not a very big error, okay? So the relative error is just telling you whether or not it's a big error. And then the percent error is the same thing, but it's just changing that number to a percent. Would you mind locking that? Thanks so much. And what number? If it's 2 plus or minus 0.05, it's going to be between 2.05. Thank you. 1.95 and 2.05. All right. So if 2 is our exact value, it actually doesn't matter if we want to use the smallest 1.05 or the largest 2.05 for our approximate, because we're going to get the same number when we do absolute value, right? Because they're both 0.05 away. So I'm just going to use the biggest one. 2.05 absolute value minus 2, and then divided by your exact 2. All right, and so go ahead and calculate that. Oh, and we want to know the percent error, so we'll have to then multiply that times 100%. If you do not have a calculator yet, now is a great time to get a calculator. And then you go over to num, and ABS is absolute value, so you press that one. And then you're going to do 2.05 minus 2. Then get outside of that absolute value. The absolute value works as a grouping symbol that's going to keep your whole numerator together. And then do divided by. And then 2. And then we can multiply times 100%. We get 2.5. Remember, that's 2.5%. That's your error, 2.5%. Does anybody want to see the absolute value again? Okay, good. All right. There are at least 3 good ways to solve systems on your calculator. The ways that we learned in Algebra 2 or even Algebra 1 to solve systems are substitution, where you substitute one equation into the other, substitution, elimination, where you add them together to eliminate a variable. Yeah. Okay, I cannot spell. Elimination. Okay, elimination. And then we would graph by hand as well. And those all take a long time. So when you do your IB test, it is timed, and the tests in the class are also timed. And so you need to be careful of your time and know the quickest way to solve things. So there are 3 ways on the calculator. The way that's on your notes is not the way we're going to do it today, because not everybody has the simultaneous equation solver on their calculator. It would be interesting to know how many of us have it. So let's try this real quick to see if we have it, but I'm pretty sure that most of us don't have it, okay? So on your calculator, we're gonna follow those directions. Here it is. All right, we press the apps button. The apps button is diagonal from the alpha button, the green one. And it might look like this ply smelt 2, and it also might look like poly, let me see mine, apps. Okay. I'm gonna scroll down to mine. It starts with P, so on this calculator I have to scroll all the way down to P. All right, so it might look like poly SMLT, or it might look like this, ply smelt 2. You press that one, and then you want to do the simultaneous equation solver, which is 2. All right. If you follow the directions but you just don't have it, raise your hand. Yeah, see, that's most of you. So what we need to do is maybe we have SS8, and during SS8 we're going to be doing rights and responsibilities. But we also could be using that time to connect the calculators so that we can get them onto your calculator. So for today, I'm not going to do, but we have 2 more methods, okay? This is the method that's described on your paper, so if you do have it, you can check that at home. The second method is to solve by graphing. And what I'm going to have you do is turn to your notes. And on the blank back of your notes, in order to solve by graphing, we're going to solve the system that's in that. We need to first isolate the y. So let's solve a system. This is really useful. We did do this when we were going over the calculator things. Here's 2x minus y equals 5, and x plus y equals 1. I wrote them side by side to leave myself some space so that I could and actually I'll write dark. All right, to get this y by itself, how do I get rid of the 2x from both sides? You could also add negative, not what you do. Your calculator will. All right, so we can divide by -1. And we get y equals positive over negative is negative, negative over negative is positive. And then this one, much easier. All we have to do is subtract the x. Y equals 1 minus x, or negative x plus 1. So what we're going to do is take these 2 equations and graph them on the calculator. So I'm just waiting for a minute for people to catch up, and then we're going to graph these on the calculator. Kenzie, we wrote this on the blank back side of our notes. So we pressed y equals negative 5 plus 2x. Go down to the next y and 1 minus x. And then the x, remember, is right next to the alpha. Who needs help finding a key on the calculator? Okay, then you're going to graph it. The graph button is right here on the top right, graph. And where the 2 lines cross is the solution that they share. Now you can kind of read it right here, but just to be sure we have it right, we're going to do calculate. Calculate is above trace. So second, calculate. We want to know where they intersect, which is choice 5. So that was second, trace 5. And it's going to ask you first curve, second curve, guess, but it actually knows where they are. I don't even know why it asks. So you're just going to press enter, enter, enter. First curved, yes. Second curve, yes. Guess, yes. All right, and so it got it, and that was our answer. Our answer is 2 comma negative 1. I think that this is an easier way, but it does require that you are able to put your equations in slope-intercept form. So you have to be able to solve for y. There is another way that is similar to the simultaneous equation solver, and this method uses matrices. And matrices may seem difficult, but the method is not difficult. It's a bit of button pushing on your calculator. So I'm going to show you this other method. I'm going to put this on the video so you don't have to write down all these steps right now. I put this here, but actually if you have room on the back, you can also put this method on the back because I did kind of run out of space. Don't write it all at the same time. In fact, I'm going to cover some of it up because what I want you to do is focus on one thing at a time. To solve with matrices, you need to make sure you have it written in standard form. Standard form is when you have the x's and the y's on the same side, and then you just have the constant terms on the other side. So x's and y's on one side and constant terms on the other side, and they have to be written in the same order. So first the x and then the y. Sorry, let me make that bigger. It's really tiny. So to solve with matrices, first you want to make sure it's written in standard notation. This problem was already written in standard notation. And then we write it as a matrix equation. In the matrix equation, you take the coefficients of the x and y. So notice this was 2x and negative 1y. So here's 2 and negative 1. This is 1x and 1y. And so here's 1 and 1. You take the coefficients and you make a matrix out of it. The next matrix is the XY matrix. So I know we haven't learned matrix multiplication, but this one times this one would give you the 2x minus y and the x plus y. So we haven't changed anything. We've just written it as a matrix multiplication. And then that's going to equal your constant terms 5 and 1. This is the way that the year 2 HL teacher does systems in her class. So if you think I don't know what the SL teacher does. She might also do this, or she might do graphing, I'm not sure. But I know the HL teacher uses this method. All right, so then we're gonna put the matrices into, actually, we're gonna solve the system matrices into the calculator. So where it says solve, here's what we're doing. If I know a number times a variable equals another number, I could divide by that number, right? Like that's how you would solve. If I told you 2x, then you would divide, right? But we can't matrices, we multiply by the inverse. Multiplying by the inverse is the same as dividing. This negative 1 here is the inverse. So we're writing it out, but then I'm following the directions I wrote down. I'm going to quit out of this, second quit. Sometimes you just want to get back to like a regular screen. I can clear that out too. And then I'm going to press second matrix. So second, and then matrix is over here. You see the x to the negative 1. That's inverse, but second matrix. You should be here. Anyone need help getting that? Okay. We want to edit matrix A, and edit is over here. So I'm going to use the right arrow to get to edit. I'm going to edit matrix A and press enter. Matrix A is not a 1 by 1 matrix. It's a what? It's a 2 by 2. So you're going to press 2 by 2. And then you're going to enter the numbers in here. 2, negative 1. Remember the negatives on the bottom. 1 and 1. Okay. Whenever I enter a matrix, the next thing I do is I do second quit just to get out of there so that I don't accidentally put a matrix into a matrix. Like that's just asking for trouble. So once I have this entered, I'm going to do second quit to get out of there. Who wants help getting matrix A? one's up. Coming. Who else wants help? Are you doing all right? You got it in? Okay. All right, second quit, and then we're going to enter matrix B. Second quit, and now I'm going to go back to the matrices. So second matrix, second quit, then second matrix. And I want to edit matrix B, so I'm going over to edit, and then down to B. Second matrix, go over to edit, go down to B. Matrix B is not a 2 by 2, it's a 2 by 1, 2 rows by 1 column. So 2 by 1. And then in the matrix, I need to enter 5 and 1. Okay. I'm going to put the directions back up so that you can see the directions. Okay, I'm quitting out of this, second quit. I'm going to pull up, I really want it to say A inverse times B. So, A, I need second matrix. Second matrix, and I'm not editing this time, I just want the name A. So I just press enter. Okay? Second matrix, and then you just press enter because you just want the name A. Then you want inverse. Inverse is the same button we've been pressing for matrix. It's this one, like that. Okay? Then you want the B. So we're going to do second matrix, and we need B, and you press enter. And then you press enter, and after all that work, it gives you the answer. Now, that might have taken us 5 years this time, because we were learning it. But when you're taking a test, if you have practiced this enough, it's not that hard. So it's really up to you for most systems to decide what you want, but I will tell you that if you have more than 2 variables, then you need this, okay? If you have 2 variables, you can graph it. If you have 3 variables, our calculators don't do that. Have you guys ever done the Desmos 3D calculator? Desmos 3D calculator will do that, but I haven't even investigated how to use that yet. So this method will be really good if you have 3 equations, 3 variables. All right, I am going to pause for a minute to answer a couple questions. I am not inviting you to take out phones right now. Thank you to those of you who noticed that there were some practice problems and got started, but it's okay if you didn't. We're just going to do those now, okay? So we have 2 practice problems. I don't mind if you do them both with graphing. I don't mind if you do them both with matrices. I don't mind if you just say, well, actually, it's just as easy to do by hand. I'm going to do it by hand. Whatever you choose is fine with me, okay? For why, so a lot of you chose to graph it, and I thought that was a good choice, but some of you wanted to try out matrices because you just learned it, and so that was also a good choice. But I decided to graph this one, so this is already solved for y, and then this one, all I had to do is subtract the x. And so you press y equals on your calculator, and you enter them, you graph them, and then second, calculate, intersect. If you had forgotten that step, you should write it down. Second, calculate, intercept, and then enter, enter, enter. So that was pretty quick, and we got 1, 2. Did you guys get 1, 2? That means x equals what number? 1, right? Yeah, so you have to be able to make sense of your answer too. So 1, 2, x is 1, y is 2. Correct. All right, the next one, maybe we put these in matrices. So just a quick review. I might not actually do all of the steps. So to do matrices, just quit out of whatever you're in. And then you need to do second matrix, and you're going to edit. Luckily, it's another 2 by 2 matrix, so you don't have to edit that part. You're just going to edit this one, and you're going to put in the coefficients. 5, -2, 3, and 2. Okay? And then I'm going to quit out of that. And I'm going to do second matrix again, do matrix B, which is again a 2 by 1, lucky. Oops, that's not what. See, I do that all the time. I do the wrong thing. Second matrix, edit. B. All right, and then go down. And this one is 7 and 17. Okay, and then once you do that, then you want to use a calculator to do A inverse times B. And you should get 3, 4. Did you guys get 3, 4? Okay. Radicals, last topic, and then we're going to do a revision village, which I will explain shortly. Okay. When you divide two radicals, guys, lots of talking. If you get it, that's great. Just quiet down for everybody else. When you have two radicals and you're dividing them, you can rewrite that as the square root of their quotient, like that, one big square root. And then you can divide 18 divided by 6, and you just get root 3. Square root of 3, that's it. It's as easy as that. When you multiply two radicals, again, you can rewrite them as the product of those two numbers under